Good day everyone. I will be continuing discussing about the basic analysis statistic. The Michigan State University Measurement and Evaluation Department reports a number of item statistics which aid in evaluating the effectiveness of an item. The first of these is the index of difficulty, which is MSU, defined as the proportion of the total group who got the item wrong. Thus, a high index indicates a difficult item, and a low index indicates an easy item. Some item analysis prefer an index of difficulty, which is the proportion of the total group who got an item right. The index may be obtained by working the proportion right option of the item analysis header. As the index of difficulty, the purpose of this is to determine the difficulty level of test items. A measure called the difficulty index is used. This measure asks teachers to calculate the proportion of students who answer the last item accurately. By looking at each alternative for multiple choice, we can also find out if there are answer choice that should be replaced. For example, let's say you gave a multiple choice quiz and there were four answer choices, A, B, C, and D. The following table illustrates how many students selected each answer choice for question number 1 and question number 2. For question number 1, we can see that A was not very good distractor. No one selected that answer. We can also compute the difficulty of the item by dividing the number of students who choose the correct answer, which is 24, by the number of 30 total students. Using this formula, the difficulty of question number 1 referred to as P is equal to 24 over 30 or 80. The rule of thumb is that if the item difficulty is more than 75, it is an easy item. If the difficulty is below 25, it is a difficult item. Given these parameters, this item could be regarded moderately easy. Lots 80%, or students got it correct. In contrast, question number 2 is much more difficult. 12 over 30 equals 40. In fact, on question number 2, more students selected an incorrect answer, which is the letter B, than selected the correct answer, which is the letter A. This item should be carefully analyzed to ensure that B is an appropriate distractor. Another measure, the discrimination index, refers to how well an assessment differentiates between high and low scores. In other words, you should be able to expect that the high-performing student would select the correct answer for each question more often than the low-performing students. If this is true, then the assessment is said to have a positive discrimination index between 0 and 1, indicating that students who receive a high total score choose the correct answer for a specific item more often than the students who had a lower overall score. If, however, you find that more of the low-performing students got a specific item correct, then the item has a negative discrimination index between -1 and 0. Let's look at an example. The table displays the result of the 10 questions in a quiz. Note that the students are arranged with the top overall scores at the top of the table. Number 1 indicates the answer was correct, while the 0 indicates it was incorrect. I will be telling you the steps to determine the difficulty index and the discrimination index. Step number 1, after the students are arranged with the highest overall scores at the top, count the number of students in the upper and lower group who got each item correct. For question number 1, there were 4 students in the top half who got it correct, and 4 students in the bottom half. Step 2. Determine the difficulty index by dividing the number who got it correct by the total number of students. For question number 1, this will be 8 over 10 or P equals 80. Step number 3, determine the discrimination index by subtracting the number of students in the lower group who got the item correct from the number of students in the upper group who got the item correct, then divide the number of students in each group. In this case, there are 5 in each group. For question number 1, that means you would subtract 4 from 4 and divide by 5, which result in discrimination index of 0. Step 4 rather, the answer for question number 1 and 3 are provided in table number 2. Now that we have the table filled in, what does it mean? We can see that question number 2 had a difficulty index of 0.30, meaning it was quite difficult. And it also had a negative discrimination index of negative 0.6, meaning that the low-performing students were more likely to get this item correct. This question should be carefully analyzed and probably deleted or changed. Our best overall question is question number 3, which had a moderate difficulty level 0.60 and discriminated extremely well 0.8. Another consideration for an item analysis is the cognitive level that is being assessed. For example, you might categorize the questions based on Bloom's taxonomy, perhaps grouping questions that address level 1 and level 2. In this manner, you will be able to determine if the difficulty index and discrimination index of those groups of questions are appropriate. For example, you might note that the majority of the questions that demand higher levels of thinking skills are too difficult or do not discriminate well. You could then concentrate on improving those questions and focus on your instructional strategies on higher level skills.